Graphing inequalities. Graph the following inequality. 7x minus y is greater than 14. Here we have a linear inequality. To graph this, we're first going to graph the linear equation. Then we're going to use a test point to decide which side of the line we can shade to represent all of the solutions to our inequality. So first, we want to take 7x minus y is greater than 14, and I'm going to write this using an equal sign. Now I want to find the x and y intercepts. Once I have 2 points to a line, I can graph the line. So I'm going to find the x-intercept, and to do that, we're just going to substitute a 0 for y. So I have 7x minus 0 equals 14. So 7x equals 14. And then we'll divide both sides by 7, and we get x equals 2. So the x-intercept is 2, 0. Now I'm going to find the y-intercept. And again, this will give me the second point on my line, so I can then graph my line. And to find the y-intercept, I'll just plug in a 0 for x. And we get 0 minus y equals 14, so a negative y equals 14. Then divide both sides by 1, and we're left with y equals a negative 14. So my y-intercept is 0, negative 14. Now I'm going to graph or plot these points. So first I'll plot 2, 0, which is here, and then 0, negative 14, which is here. Now I want to draw the line. Before we do that, look at the inequality sign. Since this is a greater than sign, it doesn't have that equal to line underneath it, so that means that I'm going to have a dashed line. So I'll just connect these dots using a dashed line. Now I want to decide what side of the line to shade to represent all of my solutions to the inequality. So I'm going to choose a test point, and you want to choose a test point that is not on the line. So I'm going to choose 0, 0. This is an easy point to choose, and it's not on my line, so I can go ahead and choose it. So to test 0, 0, I'm going to take the original inequality and plug in a 0 for x and a 0 for y. So I get 7 times 0 minus 0 is greater than 14. This becomes 0 minus 0 is greater than 14, or 0 is greater than 14. Now this is not true. 0 is not greater than 14. So the test point is not included in the solution. So that means that I'm going to shade on the other side of the line that does not have the test point. So if I go back to my equation, I'm going to shade on the right side of the line because this is the side where the test point is not included. So the answer to my problem is this graph where I have the dashed line and then everything shaded to the right of the line. Graph the following inequality. Y is greater than or equal to x squared plus 3. This is a quadratic function. In order to graph the quadratic, you're going to first find the vertex. The vertex is given by negative b over 2a. That's the x value of the vertex, and the y value is f of negative b over 2a. So first we'll find the x value, which is negative b over 2a, And there isn't a b term in this quadratic. Remember, the b is the value next to the single x, and we don't have a single x, so this is just going to be 0, and then divided by 2 times 1. So x is 0. Then we'll plug in a 0 for x and solve for y. And we get y equals 0 squared plus 3, which is y equals 3. So my vertex is 0, 3. Now I want to find two other values. I want to find a point on the right side of the vertex and a point on the left side of the vertex. So if my vertex is 0, 3, that would be here. So I want to test x equals 1 and x equals negative 1. And I'm going to find two other ordered pairs. So when I plug in a 1, I get y equals 1 squared plus 3, which is y equals 1 plus 3, which is 4. So my first ordered pair is 1, 4. And then I'll plug in a negative 1. And when I do that, I get y equals negative 1 squared plus 3, which is y equals 1 plus 3. And again, I get 4. So my second ordered pair is negative 1, 4. If we go back to our graph, so when I plug in a 0 for x and a 0 for y into the original inequality, I get 0 is greater than or equal to 3. That is not a true statement, so that means that my test point is not going to be included in my shading. So when I go up to my graph, I'm going to shade inside the parabola since my test point is not inside. So the answer to my problem is the graph of the parabola with the inside shaded.